Hi there, folks. This is Alan again, and I'm going to try to kill two birds with one stone today. I was on Hobby King earlier, and somebody had asked a question about something I happen to own, so I gave them a quick answer and then said I'd make a video, so I'm doing that now. What we're working with today is, first of all, the Turnigy Servo tester. It's that little black box with the red knob, big red knob, or the red box with the black knob, or whatever combination they happen to throw plastic at that day. Actually happens to be a very good servo tester. I'm going to take it apart. The other thing, oh, by the way, it has a manual. Read it. The other thing we're playing with today is the Dr. Mad Thrust Smart Controller for Electric Retract. Now, this is a little bit of a odd bird, and this is what the nice person on Hobby King asked me about, or just asked in general. I answered. It's a unique unit in that, as I described to him, just think of it as a Y connector from the output of your receiver, whatever channel, 5 or whatever, that you have your gear on. And that Y connector then goes out to your servos. Well, this is actually a circuit board that does that Y function, but it has one very unique and very, very good feature to it. So I'm gonna talk about that some and show how it works and things. It also comes with a manual. You know what I'm gonna say next. Read it. Okay, so let's get to the parts, because I'm losing light, and since I moved my workshop, I haven't got everything set up. This particular bench is upstairs, the main shop is downstairs, and I don't have video capability down there yet, so I'm just winging it up here. But this is actually where I do most of my work. So I do promise I'll get on to try a couple of cameras that actually work. I'm using the Logitech 920s, which are wonderful cameras, unlike the Microsoft ones. Anyway, so let me show you what we got, and then we'll start really digging in. And you'll have to pardon again the playing around with the video here. So, okay. Because my other camera, which is up in here, is not capable of working with this software. I've got to train it out and all that happy garbage. Anyway, so what we've got, and this is going to be a little bit silly, but there's a reason I'm going through it. We've got battery. This is actually another Hobby King product that I've actually ripped out of the case, because what it is it's the one that you see online, where it's got a nice little faceplate and on-off switch, and it's got a digital voltage display. I happen to need a BEC, which is what this is, with a toggle in a small form factor. And for another project, I needed a digital voltage display. So I looked at what I could find, and the cheapest way to go was to buy that product. I forgot the number of it and stuff, but you can find it online if you're interested. And I opened it up, took it apart, and clipped out the digital display. And I'm having trouble with focus, so let me try to do this. And it's not going to cooperate. Alright, we'll leave it alone. So that's what this is. And the basically I just wanted this for the bench for doing this kind of thing. And the digital displays elsewhere. So battery is going into this, which is your BEC, like you would have from your ESC or whatever you have on board, and that's powering. This is the servo tester. That power is coming in on the power side, and I've got connected to it. This is my little jig that I use for demonstrating for the kids and stuff. Multiple servos and the concept of retracts and everything else all at once. So this is just a plastic U channel with 2 real cheap retracts in it, and then a 900 series of the what are those? I keep forgetting what they call them. Hextronic HXT 900. That's the 9-gram servo. Everybody should have 50 million of them. They're cheap, and they come in handy for all sorts of things. So, then this is the mad thrust unit, and I'll try to get you a better picture of it a little bit later, because there's something important here. Unfortunately, the other camera isn't working, which would have shown it real well. So I've got this, like it was. Think of this as channel 5 or your gear channel on your receiver coming into this, and it splits the signal out to these 2 retracts. Now there are 3 spots on this, so that you can actually have all 3 retracts plugged into it. So it's really not a Y, it's a triple parallel connection. So let's turn it on and see what happens here. Power on. Okay. Now, this one right now is in manual mode. This is the next light is for centering or neutral, and then this is auto. And yes, the knob controls the speed on auto. And this is actually a very good potentiometer. The feel of it is very, very good, and the resolution seems very good. So what I'm going to do here is you'll have to, it's a problem with not having the right camera. I'm right now at neutral. So if I go down, I need to do it this way. So if I pull it down, you'll see this one is also indicating for you where I am in the whole scheme of things with the output of this. So these are, the light's not right for here. Damn it. Alright, that's better. That'll work. So we'll bring this over. There's neutral. And right about at neutral, just a hair more, the mad thrust unit kicks in and brings the retracts basically up, because this is upside down from the way it should be. Now, this is what's cool about this unit. Like I said, just think of it as a parallel connector from your gear channel to how you're up to 3 servos. But right now the gears are retracted. And let's say I want to show the model to somebody and I want the gears down. Well, it's sort of silly to have to go through the whole mess of powering up the whole system with your transmitter and everything else and fumbling around, when you can just press one button and do it. Now, the neat thing is, even though I've activated the retracts and the retracts are now down. So this is, like I said, this is upside down. I can still control it with servo, which is pretending to be the receiver. And the lights on this always indicate to you what mode it's in. Okay. Now, I've got them up. Now let's say I want to put the model away or something else. Again, I want to change the position. Push the button. Done. Push it again. Done. And it matters not unless it's triggered this way. But even then, you can, well, I didn't get it past that. You can hit the button and cause it to go. So what this does is it's a manual way of overriding whatever is going on with the receiver. Now, this is the fun thing. As long as this has power going to it, whether your receiver is on or off, it doesn't care. It will still work by just pushing the button. So if you're like I am, where I'm designing systems where I have auxiliary batteries, and then I have receiver batteries, and then I have motor batteries. Well, this can be on the auxiliary battery for FX, special effects, and stuff like that. So I don't even need the receiver turned on or drawing power. I certainly don't need the ESCs on for the motors, and I can still retract. It's beautiful. Now, normally, let's see, what else was I saying? Okay, let me, let's go to non-center, centered, and then I'll turn that down because it's going to. Well, this is pretty obvious, but this is what's happening. Just so you, and I've got this one here so you can see what this thing is outputting. Now, I can crank that up, which is a little mean for the retract, but they'll get over it. Like I said, this controls the speed. So this is really a great setup. Now, let me stop, turn things off, and start dissecting here. First thing I want to talk about is this. And I'll post this video to both products and whatnot. So let me get all that out of the way. Now, this is going to be fun. All right. I'm going to try to hold this still long enough for it to hopefully focus or not. And give it a little bit more focal range here. Not going to happen. Crap. Oh well. Alright. Come on, baby. Alright, this should do it. Alright. There's the board. And it's real clean. Let me back up a little bit because I just can't hold it still long enough. I got my camera too high. Now normally this comes with a plastic sheet over it with just a hole for the button there, which I immediately cut off, and there's a reason for that. First thing I saw through the clear plastic Let me get a better focal range here. There, that worked. Okay. First thing I noticed was this set of contacts here. And I actually saw them in the picture online. And I said, interesting. And what's even more interesting is it is labeled as in a remote control for this board. So I took my flute ohm meter and traced the circuitry, checked it out. The pad that's in the center here is ground, and the pin closest to the ground pin here, that one is the signal, and it's routed over here to the chip. Well, guess what? Somebody in marketing or wherever decided that, gee, this was just too cheap a price of a unit to give us all the features, and it doesn't seem to be programmed in the chip. So, with that said, I figured, well, let's dig around some more. So, on the switch, and get the light right, and angle of the tongue, as our other friend will say. These two pins here, that one and that one on the switch, those two pins, if you solder a wire to each of those and route it out of here, and you short those two wires, you're doing the same exact thing as pushing this button. So you're basically wiring another button in parallel. So this doesn't have to be mounted somewhere. I mean, that's the stupid part about this, is you don't have a remote button. You only have the button on the board. So you can get around that, like I say, by taking off the heat shrink that it comes with, and then I'm having to think backwards here, which I don't do real well. So just solder to that pin and that pin. Two wires, 1, 2, and go out. And don't hook them to anything other than another switch. And I don't get carried away. And then you'll have remote. And that's what I'm going to do with this pump. So this will be buried deep in the body, and I can still push the button, but I'll have a button on the outside as well to cause all sorts of nifty and wonderful things to happen. Okay, so that's this one. There was a question about current draw on this. You know, how much current can it supply? And I'll get to that in a minute. But with any of these parts, you know, for God's sakes, be reasonable. You know, you got these small wires. This is not a 10 amp wire. This is minuscule amperage. Alright? And don't connect 50 million servos to the output. It's not going to be able to handle it. This is designed for basically 1, maybe 2, but since these are all in parallel, you've already got 3 hooked to the output. I wouldn't push it. I really wouldn't push it. The only way to really tell, because they don't give you specs on stuff, which is a shame, but what do you want for a cheap part? The old adage. The only way to really tell is to hook it up, hope for the best, and because the driver seems, you know, I'm not seeing any MOSFETs on here. I'm not seeing any kind of, it's just that chip. So whatever that chip is capable of carrying, you know, that would be it. Problem is, of course, there's no labeling on the chip, so you're clueless. So the only good way to find out how much amperage this thing will really supply is to hook it up, put a current load on it, and blow it out. I don't recommend it. So let's go to this pump, and let's go back to autofocus. All right, and we can move in. All right, now the question that was posed was, this gentleman has a project, and I would suspect it's not mobile based, because he was talking about buying one of those bricks from Adafruit that provides 5 volts out at a high amperage, and he's talking like 5 to 10 amps. He's got big servos, evidently, and you know, if they go into stall mode, he thinks they would pull up to 10 amps. Now, my answer to him was, you know, you basically, again, what you go in with is what you come out with on these things. But there's a way around that, and I'll explain it. And I probably should draw a picture as well. Hold on a second. Okay. Let's see if I can do this on the fly here in a minute. All right, now, most people conceptually think that, okay, I've got power in, I've got power out, and I can draw as much as I want. Wrong. And there are a couple of reasons for that, and I'll show you why. Now, on the power side of things, you actually have an advantage with this thing over some other types of parts, like this. And let me disconnect power, and I'll show you now. Since there have been people that have complained about me unscrewing things and whatnot, and they have no patience. Through magic of good old video. Ta-da! I did it ahead of time. Now in this case, I don't mind doing that because it's really 4 screws, which is wonderful. This is a nice product. Screws count for a lot in my world. Instead of having to break plastic to get things apart. But it's important sometimes to show how something comes apart, because on some of these things, like one of my next rip apart and actually repair projects, I've already taken it apart, and let me tell you, it was a bear to do. I had a hell of a time with it, and I don't know if I'm not even going to pop it back together to show it coming apart again on screen, because trust me, it was a mother. All right, so now this will be a little dicey, because I am going to do this on screen. This knob is controlling a fairly large pot. Now, how can I tell that? Back to the strange focus. All right, now, if you, where am I? Okay, now, you look, that right there, and that right there are, I'm willing to bet you, mounting points for this big potentiometer that's in there. And then these are the actual 3 connections for the potentiometer down here. Okay, so what we've got in here is your going to be, I don't have the right glasses on. second. Hold on. Here's the problem when you've got problems with close vision. Ooh, bad. All right. So you've got you've got power monitoring and stuff, you know, power supply type stuff in here, because this accepts a wide range in. But whatever you give it in is what it comes out with. The power regulation that's in here is for this chip. Period. That's all it's doing. It is not regulating or futzing around, you know, to a major degree with these things. So don't go nuts with it. It does look like there's coming across. Yeah. Okay, so if you look here, and back to the other glasses. Pain in the butt. These traces that are here, if you look, there's a big trace that goes to all of these connectors. Now, on the other side of the board is going to be another trace that's going to supply looks like you're negative, because this trace is actually going to the center position of each of these, which is positive. That's sort of interesting. Let's see here. Okay, it is going through this, and then it's coming across. Ooh, interesting. Okay, so let's get into here. I think it's very valuable to know what's in things that you buy, so you have a better understanding of what you can do with them. And don't panic. Again, I actually bought this to tear apart, so no big deal. And this is going to be a little bit of a bear. I hope they didn't glue this knob, but they might have. There it goes. Okay. Thank you. All right, now I can get this out of here. Oops, sorry. Okay. Yeah, this is what I thought. Okay. All the circuitry is on the other side, which is actually very nice. I mean, this is a very nice, clean build, and this, let me tell you, that almost looks like a Bourne's or a Bourne's ripoff. That's a nice pot. That's a good one. Like I said, the feel of it is just silky smooth. I mean, anyway, so what's going on here is this big plane here is connecting to one of the pins for power, and then this plane here is connecting to the other. So if you're throwing a lot of power in here, let's see, power in is, sure enough, see positive here coming in. That's that's their input pins right there. So that center one is positive. Well, that's this trace, which is also going to the center of all of these. Now the other side is going to be hidden. Can't see it. All right. I could meter it. Let's see. I'm pretty certain that's what's going on. So, you know, as far as current goes here, you're probably limited by how much this trace, because this is the smaller trace, is able to handle. So you draw a lot of current from these pins, what's going to go poof magic smoke is probably your trace before anything else does. Now, the thing you have to understand is the way these work. Two of the pins are providing power. Okay? The third pin is your signal. Your signal is always a low current signal, relatively low current, and it is a positive spike up to do the timing in reference to ground. So, like earlier, I hooked up my oscilloscope just to make sure what this was outputting, which actually is a very clean wave, very clean. I mean, considering the price of it. So these are outputting plus. So you could take a power supply, okay, and input here, and then just pick off of this one the signal lines. And that's what I actually have a cord that does that. This is a special adapter cord that I've got for monkeying around with things. This is, okay, it goes in this way, normally, where you have signal, then you have positive, and then you have your negative. Now, as you can see here, I've got two connectors. If you put those two together like that, you've got your standard 3-pin connector. It'll plug into anything. But you can pull that apart, or I can, and I can run this off of a separate power supply, and this is the signal output line for a servo. And as long as your two power sources, and this is just generally good practice anyway, where the grounds of the power supplies, each individual power supply, the ground, the negative, the black, the brown, whatever color it is, whatever is negative, are all tied together, it won't matter. This will still output the signal that's necessary to run the servo. So the guy that's doing the project, you know, he could take literally, you know, a bigger battery, and not this one, I have a monster, but this could be connected through a BEC that's capable of the current draw that he's going to be using. It's 5 volts, maximum 10 amps. Okay, you know, that's going to be a pretty pricey BEC. So that this can power that. Right? Just imagine this big battery capable of 10 amps. You know, oomph. So this connects just the power leads on the servos. And as long as this ground lead, that right there, is also electrically connected to the output of your other BEC, and the servo connector is there, it'll still work. So you can have a low current supply that's powering this, and you can separately supply these big servos and things that he's talking about through a separate power supply chain, as long as the negatives are intact. Now, one very strong caution: do not, and I repeat, do not ever connect both power supplies, red and black, in parallel. Bad, 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 bad. Only the negative, because you're creating a commonality from reference ground negative for the servos and for this and for all your other circuitry. If you put the outputs of two power supplies together, you're going to have bucking problems. It just gets to be an absolute nightmare, and blue smoke is inevitably in your future. I see it in your fortune. So don't do that. Actually, I'll hold off on doing it on paper. If you want more explanation, if you want a diagram, I'll do one. Let me know, and see what you think about this little bit of tearing apart, ripping apart. I'll put it back together, and yeah, it'll still work. But I hope that clarifies a little bit on this unit, which is great. I mean, this is a good idea. Not having this working, bad idea. You know, and I've tried all sorts of combinations on it, and I have not been able to get it to go. So I'm assuming, and especially since they put the heat shrink over it, that it's just not programmed in the chip, because it's just another logic input. And this is good. So that's probably a long enough ramble. It's 36 minutes. Yeah, that's way long enough. These will get shorter. They'll get better when the video stuff is easier to handle. So hang in there with me on that. If you enjoyed it or not, comment. Let me know your thoughts. Good and bad, doesn't matter. You know, any constructive conversation is good conversation. Just bashing people is like useless. You might as well go do something else. Like, anyway, there are other videos, and they're all on SynergyHub.org, and in the SynergyHub YouTube page, and you can look at them there. And let me know what you think. And if I've said anything that you think is bogus, hey, say something. I mean, I learn something every day. But I try to give you all something as well. So you all take care, have fun, fly safe, and don't fly over people.